The Building Supply Company has been at the forefront of building innovations for over 25 years, and we're about to show you the latest in Hebel modular panel systems. Stay with us while we visit a building site that's been under construction for some time now, showing the benefits of the Hebel solid panel systems, identifying the frustrations that builders and developers get with dealing with bricklayers, waste on site, overruns, and this will clearly identify the benefits of using a Hebel solid modular wall system. The system I'm about to show you is a 250mm blade bearing commercial wall panel used as a domestic application. So there's no structural steel supporting the wall structures at all, and obviously has some huge advantages with the system. We've been involved on this site for about 3 days now installing Hebel panels, so you can see the productivity, the speed of erection, and what we call is the accidental advantages that we've come along the way. In particular, the use or the lack of use of scaffolding required because we're working behind wall faces, and which is significant cost benefits. So as you can see, 3 days work. 3/4 of the panels have been installed. We'll go through some of the details to this date. This is our third project. The project we've done before are now 4 years old, so there's good longevity in the system. You'll find that the tie-down details, the control movement, because we're using a panel system rather than a block system, has some huge advantages. But if you look at these panels here, so you can see we've got a 250mm thick Hebel panel. That achieves an R rating of 2.5 in itself. In some areas where a higher rating is required, you may just have to use an internal batten and create some airspace, which will get you to your 2.7. But you can see this panel here is 5.3 metres long. Within this panel there's 375 bricks. So can you imagine that as a double skin brickwork, how long that would take to install? Okay, we're just about got the crews in order here. They're going to bring the crane and the jib down. We're going to take this panel here, which is 5.3 metres long, and it'll be positioned on top of that wall as the top panel. One of the big advantages with this system here is the lack of steel required for openings for lintels, as these act as beams. As you can see at the end of the panel, there's 2 layers of reinforcing cast into the panel, so the structural side of the panel acts as a beam in itself. So Treat might just bring that down now and we'll put the grab on. You can see in the structure where this panel is going, there's 2 tie-down rods at each end of the panel. They go all the way through the panel, so you can see in the panel they've been caught out. The rods will pass through these grout holes and they will get grouted in, so the structural integrity of that panel wall is significant when you've got a tie-down rod both ends of the panel. It has some huge wind loads and probably ideal for cyclonic areas. They can be beefed up accordingly. You can see the ease of the grab that's just connected to it. That panel will probably weigh around about 500 to 550 kilos, so there's some significant weight in it. The crane that we're using here is quite a large crane because we have to reach to the back of the building, and the crane cycling needs to be fairly significant. On other sites that we've used cranes, they haven't been that big because we've got the luxury here of having a fairly large area to lay panels out. In an urban site we don't have that luxury, so it's a matter of strategic planning and coordinating deliveries in the right sequence so panels can be offloaded in the same way that they're installed. So the panels are just being prepared now. Quite often there's a few dags under the panels for manufacturing process that have to be cleaned out, and if you follow me we might just go for a walk around the building to show you the rear side of it. So this will probably give you a bit more of an idea of the number of panels that we have done in 3 days. This will probably be our last day with the crane, so we'll be just topping off all of these top panels at the moment. These walls are 3 metres high. We can do a 2.7 high traditional wall height by just introducing a 300mm panel as a base panel to start with. The base panels in this application have the damp course layer on the blockwork, and we have used a 200mm Hebel floor panel system on this project, obviously to try and create that maximum thermal cube that we're trying to achieve thermal efficiencies. So you can see it's lifting in at the moment. Normally at this stage of construction, if this was double brickwork, there would be scaffold all the way around the perimeter of this wall, the house. So that's a huge cost saving. There will have to be scaffold used eventually, but that's mainly for edge protection and fascia and gutter, so We've probably cut down at least 2 to 3 weeks in scaffold hire on this project, so that's certainly a big advantage. The panel is bedded with Hebel adhesive, so on both sides of the tongue and groove joint there is Hebel adhesive that bonds the panel as well. We use a flexible adhesive. Because of the 250mm thick nature of the panel, the wall structure stays fairly straight and plumb. It's critical that the first panel is put in plumb and straight and square. The time spent on that is well worth it because the walls will just follow the panel up. The panels are fairly precise in the manufacturing process. Occasionally we might have to put a small wedge in it to pull the panel back plumb, but these have been extremely good, and you'll see that the walls are straight and true, and coatings that are applied over later on are just generally basically acrylic rendered systems. So that panel's in place now, and just an estimate, I think that's probably taken about 5 minutes to lay 375 bricks. At the end of each panel we have a control joint, a 10mm control joint. That allows for the minor building movement that's required in all buildings. That's filled with a backing rod and polyurethane sealant, so it makes it waterproof both internally and externally. At the base of the panels, these panels are laid in a non-shrink grout on packers, so, which is lasered levelled, and we fill that joint also with a polyurethane sealant. In this application, because it's not a slab edge, we actually will be putting a 75mm Hebel panel over that as a feature to disguise all of that, the floor panels and the Hebel wall panels. The joints between the two panels, there is an expansion tie that we put in place, which we'll show you at a later detail. So what we've developed is a starter angle, which is adjustable. So at the start of the job, we set out the walls, we flick the lines, we apply these angles, and then the panel is installed and positioned against the vertical face of the adjustable angle. The turnbuckle is then adjusted to make it plumb. The panel is brought in, clamped together, and the corner is formed. Once the corner is formed, that holds the panel up in a vertical and secures it. Then the angles can be taken away. So from that process, and the wall just grows. As you see, the speed of it is quite incredible. So these rods pass all the way through the wall, down onto through the floor slab, through the footing. The connection points between the panels, we have the tie bridging the walls, driven with 2 V-nails into the plate, and that secures all the wall. Environmentally, Hebel uses 60% less embodied energy to manufacture compared to clay bricks and blocks, so there's certainly a huge environmental bend on the Hebel systems. For many years in the building industry, the common perception was that the only available double skin masonry was 2 skins of clay brick. The reality is this clay brick only gives you 0.2 of a thermal rating. The combined effort of a double skin brickwork in reality is 0.6. For many years everybody thought that was probably the optimum in full masonry thermal performance. Well, I'll show you the difference. If we have 1 skin there, that's a traditional wall thickness for a 240 double skin brickwork. Obviously the 250 Hebel wall skin, as I said, is a 2.5 R rating, which gives you extreme thermal ratings. Plain to see, there's a huge difference. One of the huge advantages of this system is the labour resources used. No longer do you require a team of bricklayers to come in and lay a full masonry system. This panel system, which we constructed within a 5-day cycle of 2 days of preparation and 3 days of craning, was done with an average of 3 guys. The skill levels were building and carpenter levels, so no longer are you chasing through to bricklayers and labourers. We talked about the waste involved in building sites and the cost involved in getting the waste to disposal. This here is a sole pile of Hebel that's left over from constructing 250 square metres of Hebel wall. So you can see it's minimal. I mean, on a job like this, to have that much waste left over compared to what you would have with double brick is just a huge benefit. You can see here the guys are just doing the final completion of the panels. They're installing the top plate. Top plates are just bolted down at 900 centimetres through the middle of the panel. You can see the threaded rod have actually been drilled into the panel 500 deep, so that gives you enough kilonewton purchase on the panel and the top plate to hold the trusses down.